So for this question here, we are asked about this formula here, which we don't really use. But the important thing to remember about this formula, which I told you that this v squared equals v0 squared plus 2a delta x, which is the version of this, is that this formula is a combination of these two formulas. So this formula comes from these. So any assumptions about this formula will require the same assumptions that come from these formulas. And that assumption is, that fundamental assumption is that the acceleration is constant. If the acceleration is not constant, then there is jerk. So so if the acceleration is constant, there is no jerk or zero jerk. And so if there's zero jerk, it doesn't need to be taken into account with this formula. So in any case, the acceleration must be constant is the key assumption for both of these formulas. So when you solve this one for t and put it in here and come up with this expression up here, then the same thing must be true. The acceleration must be constant. So if the acceleration is constant, it's a vector, and vector has magnitude and direction. So in looking at this question, it's difficult to tease out if we don't do that work first. So we need to identify what two conditions are necessary for the equation to apply. So constant direction, if it's going to have constant velocity, it must have constant direction, must have constant magnitude. But of the two of those, we definitely know the magnitude has to be constant. And then upon further inspection, the direction does too, but the magnitude is key. So then we've got the initial and final velocities in the same direction. Oh, so now we've got direction. So this one says the magnitude and direction must be constant for that to apply. And so this other idea about the directions and all that are not important. What is fundamentally important is that the acceleration itself, its magnitude and direction, are constant.